New thing today, you have to be able to place your negatives and positives on a number line. You also want to, Evan, I'm going to wait. You want to be able to write mixed numbers as improper fractions. And you want to be able to think of different examples where you see negatives. And we're going to talk about those first. Like the football game last night, right? In football, some of you are sports people. You use negatives in football all the time, even if you don't realize it. When you get, like if a receiver catches the ball and runs to make a touchdown and they don't make it all the way, but they're running in the right direction, they're gaining yardage. Okay, so that's a positive gain. And in football, you want to keep going towards your end zone, right? But you guys, even if you're not football fans, it's almost impossible to live around here and not have seen a little bit of football. Your receiver could be making a big run towards the end zone, and they might get a first down, which means they take the ball. But the next time that they get the ball, they get pushed back. And so they just get pushed back. They go backwards, So they overall, in maybe these two plays, they gain only 20 yards. Can you see that? Because they went 30 one way, but then they got pushed back 10. That's a negative and a positive math problem. And it's easy for most people to do that because it has like a game to go with it, right? So that's one place you guys have talked about negatives and positives. And if you think about it, another place that you think about negatives and positives is elevation. Like Denver's the mile-high city, right? Yeah. So Denver's at like 5280, right? And I grew up in San Francisco, and San Francisco is at sea level. The beach is right there. Louisville is way above sea level. It's like over 5,000 feet above sea level. Death Valley is actually below sea level. There's a state park there. It's a place in the United States that's below the level of the ocean.
And how is water not just flooding through it?
Well, not anymore. It's like the Grand Canyon.
Oh.
It's not the Grand Canyon, but it's that idea where it's just lower than sea level, but it's not through the crust of the earth to, something. It's just dirt, so water in a lot of places, even this area at one place have water.
But like, if this is Death Valley and then this is the water, how would the water?
Because Death Valley is not near San Francisco. It's inland.
Oh.
Okay. Yeah. So when we talk about below sea level, we talk about negative numbers. Our altitude is positive, but some altitudes are negative. Below sea level, Death Valley has it's like negative 200 and something feet below sea level. So the other place is thermometers, right? So we talked about the temperature a little bit. We're not very common below zero here. It's very uncommon, but it happens. I know because there are mornings I get up in the winter and I go run, and it's about 5 degrees I can deal, 5 degrees. But when it's 5 degrees with a wind chill that brings it below 5, I don't go running.
I hate it.
But what I wanted to show you is like this thermometer is basically just a number line, except for we put the negatives on the left. So a thermometer is just a number line. But we read the thermometer probably because originally I think they were with mercury in them. So probably because it had something to do with the way that moved. I don't know for sure. But
I bet the mercury contracted when it got colder and expanded.
Yeah, and it would go up and down, and maybe it has to do with gravity. That would be something that I can learn from your science background. But when you guys see negatives, you shouldn't feel like it's brand new because, your world has them. You just have to start thinking about how to operate with them. So here's what I want to do. I wanted to show you I want you to take some notes, but I also want to help you do some placing of negatives. One of the things is when you count to the left, your numbers, they get bigger in what we call the absolute value. Like they're like they're counting up, 1, 2, 3, 4, 5, but -5 is smaller than 0, right? So as we go to the left on the number line, our numbers get smaller. And that makes sense for you guys up here, right? Like, 5 is bigger than 1 because 1 is to the left of 5. It just works that way the whole time. Going to the left, we go smaller. Going to the right, it's bigger. Okay? If you want to place a number like 3/4 on the number line, what you need to do, just think about breaking that. If I blew that 0 to 1 up, I just said this is 0 and this is 1. We've been doing this for 2 weeks now. I could break this into fourths, right? And so you can visualize in your head this, right? And you know that it's 3/4 is 3/4 of the way to 1. So basically, if you look at kind of this going on in your head, 3/4, if I shrink it up, it has to be between 0 and 1, right? So what your job is to do is just to, you don't have to draw that little number line, but just to kind of imagine those little parts fit in there all the time. So when you're asked to place 3/4, if there's enough spacing, you just draw an arrow and place it. So I know you guys can place 3/4 because we've been dealing with positives. So placing -2/3, the same idea would happen. You would just go between 0 and -1 because it's to the left. But you would still treat it like 1/3, 2/3, 3/3. So in your head, you've got to visualize the thirds and realize you're counting down. So you're going to go 2 of the jumps. So that's -2/3. Does that make sense? Yes or no?
Wouldn't that be -2/4? Oh wait, no, never mind.
Because I made 3 jumps that time. Okay.
Why couldn't you just call it 1? What
Because I was trying to place this -2/3 up there. Right here. So now I want to place 10/6. So that's where using your ratio tables, yeah, Mark, or reducing can help. No, you're mixing up your denominators. So remember, this is the same as 5 over what?
3, 5 over 3.
You guys all know that? You could divide by 2. Here. You could reduce, in other words. Do you get that?
Yep.
And 3 goes, remember when we changed to a mixed number, we did a lot of this last week, we always came the same denominator in the bottom. So 3 goes into 5 one time. And what's left over? 2. So think about how that works with your picture here. If I take I'm going to just take the red out for a minute and keep the arrow for the 3/4. But if I went to thirds and went 5/3, 1/3, 2/3, 3/3, 4/3, 5/3, can you see that's one whole jump?
Wait, how'd you get the 2?
And 2/3?
How'd you
Like visually, do you see that? There's a reason the rule works. If you just count it thirds, 1/3, 2/3, 3/3, that's a whole, right? 4/3, 5/3. Right there is your 10/6, which is your 5/3. It's the same thing. It is the same as 1 and 2/3. The reason I kept the third, Max, is because you divide 3 into 5. and it goes one whole time, right?
Yeah, but how'd you get the 2?
The leftover, when you do that division, the remainder,
Or could you just like subtract 3 from 5?
sometimes, but in this case it works, it doesn't always work, and let me give you an example. So your remainder becomes the numerator of your new fraction. It means so let me answer one question at a time. So the third comes from, the 2 comes from the remainder. Does that make sense? But your question's really a good question, because it doesn't always work that you could just subtract the 5 and the 3 to get the remainder. And in fact, because I was expecting somebody to ask that question, we're going to show that with the negative 15/4 in a minute. Okay?
I don't know how to do long division.
Okay, so you don't really need to, but it's something that you should work on. But we're going to, so 3/4 was kind of over here, about, right? I'm just putting it back. Okay, so raise your hand if you can place the 3 that we've placed. Do you have questions on it? The ones that we did, you understand how to put negative 2/3 in place? Yeah, and 3/4 in place? And 10/6 in place? Okay. So if I wanted to do 15/4 in place, I have to think about negative 15/4. So negative 15/4, what I know is that 4 goes into 15. I can just count up 4, 8, 12. It goes in 3 whole times. So I'm still going to have a negative number, but it goes in 3 whole times. What's the remainder? 3 out of 4. So if you just think about a different number line for a minute, 15/4, the picture of it should make sense. If these were all 4s, 1/4, 2/4, 3/4, that's 4/4. 5/4, 6/4, 7/4, 8/4, which is really 2, right? 9/4, 10/4, 11/4, 12/4. That's really 3. 13/4, 14/4, 15/4. That's where I stop. But 16/4 is 4. But I'm at 15/4. I did positive. I should put a positive there. Okay, so that's the same as 1 whole, 2 whole, 3 wholes, and 3/4. So when you do the long division, 4 goes into 15 3 whole times. 4 times 3 is 12, and then you get a remainder of 3. But you don't have to do long division to do that. Does that make sense? So if I had a negative 15/4, it would just be that same distance going to the left. 3 wholes. So this is the same as negative 3 wholes and 3/4. Does that make sense? So if I were going to place that, I would just start at 0 and go 1, 2, 3, and then I would go 1, 2, 3 out of 4, and put negative 15/4, which is the same as negative 3 and 3/4. That's a part of your homework tonight, being able to place numbers. You don't have to place them all on one number line all the time. That's a lot for one number line. We okay with that? Okay. So you should make, don't just do the rule, try to make sense of the picture. So we're going to go we're going to go the other direction. If you have a mixed number, you should be able to write it as improper. And I know you guys, some of you have learned rules for that, which is great. Like the rules, but we want to make sure that they make sense. So let's make sense of this first. If I do 3 and 2/3, that's 3. I'm going to go all the way to 4. You guys agree that would be 4? Okay. But I want 3 So I want 3, but I just want 2/3, right? So I want like that. That's where I want to end, 3 2/3. And I want to know what that is in an improper fraction. So I want to know how many thirds it is, because I could write that as thirds. So I have 1, 2, 3/3 here. So who can answer the question for me? Okay, Andrew. How'd you get it?
It is, I saw that
Yeah, there's 3/3 here, so another set would be 6/3, 3/3 in a whole. Good use of your vocabulary. Then 9/3, and then what? And then 2 extra. Max?
Yeah.
You should write the notes down, right? That's why we're doing this. So, and the 2 extra make 10, 11. So that's 11/3. So there's a shortcut rule. How many people have done that? Yeah. You multiply these, and you get 9, right? I'm going to just put it there. And then you're going to do what with that 9? Add the 2, and you get the 11. Okay? So, good job. So let's just practice that. Like if I have, you know, a negative number, -2 4/5, you could just ignore the negative for a minute. It's just like a positive, it's just the other direction. But the idea is that you maybe use a rule, which is fine if you're already really good at the rule. If it's new, you kind of want to, well, why don't we do positive for a minute, and then we'll look at the negative. So if I do positive, I'm going to go 2 wholes, and then 1, 2, 3, 4, 5. So that's like my 3rd whole, but I'm only going to here. So this is 1, 2, 3 would be all the way to there, but I stopped right here, 2 4/5. So with Andrew's kind of reasoning, each whole can be broken into how many parts? What do I want to break it into? 5, right? I want to break it into my denominator. 1, 2, 3, 4, 5. I mean, you don't have to draw that, but you should be thinking this is 5/5. So this would be 10/5, because I can fit 5 little jumps in there. And then I'm going to go 4 more fifths. So altogether, how many fifths have I gone? Yeah, Sebastian. 14, right? So 2 4/5 is the same as 14 fifths. And then if you use the rule, you do 2 times 5 and you get 10. And then you add 4 to it and you get 14 fifths. Okay, if it was -2 4/5, your answer is just -14 fifths, because the negative is just saying it's on the other side of 0. It's just to the left of 0. It's a direction change. I think people understand that. Okay. So, can you do me a favor and take your red book out? The bits and pieces book? And look at page 82. I didn't do the lesson in the book today, but we'll talk more about the lesson. That's kind of mostly what was in the lesson. So listen to what I have to say, boys and girls. On page 82, the beginning of the problems ask you to locate numbers on a number line like this. But instead of between -5 and 5, it's between 0 and -10. You need to draw those out, right? And just locate them. Then, when you go through to exercise 5. Exercise 5 is changing mixed numbers to improper. So doing what we just did on this page.
So that's 5.
5 to 8. And then when you go
Oh.
to the exercise 9, it's doing what we did in the beginning, changing impropers, like this one, right here, to mix, which we did right there, which we did a lot more of that last week. Does that make sense? So you have notes on that, and then when you go to 15, it's a football problem, thinking about gains and losses of yards. So a lot of the notes. There are a few other things that have a little bit different directions, but if you get stuck, you should read start your reading on page 61, and it gives more examples. So I'm gonna add in there, you know, you can also read page 61 to 64. It's just more examples. Avery.
So for 5, 6, 9, and 10, should we make number lines?
You don't have to. You can if it helps you. Depends on the person where they're at in their learning. Does that make sense? Okay,